we're going to be talking about recognizing and applying properties of both rhombi and squares. We're also going to be able to determine whether quadrilaterals, here we get even more specific, because listen up, guys. We're going to be talking about whether quadrilaterals are rhombi or squares today. So we've got multiple types of quadrilaterals. We have a standard quadrilateral, which is a four-sided shape. We have a parallelogram where opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, the diagonals bisect each other, they cut each other in half. We also have rectangles, which are parallelograms with four right angles, which means all the things we just talked about for parallelograms is true, and the diagonals are congruent, and each angle is 90 degrees. So here we go. We just did the little explore activity right here. And a rhombus. Pretty basic definition. It's a parallelogram with four congruent side lengths. That's the basic definition of a rhombus.
Copy.
Yeah. Go for it. Basic definition is parallelogram, four sides are congruent. So all the things that we know about parallelograms apply to a rhombus. Opposite sides are congruent, which obviously they'd have to be if all four sides are congruent. But that also means that the diagonals cut each other in half, they bisect each other. Opposite angles are still congruent. Consecutive angles are still supplementary. And 19. And we saw this as well. The diagonals are perpendicular. The diagonals are not necessarily congruent. They are congruent if it is both a rhombus and a rectangle, which is square. But at the very least, the diagonals are perpendicular to each other, which means that when you draw diagonals through a rhombus, you end up with four right triangles. That has to happen that way. All right, then, not only are, this is something else that we actually did not see in the warm-up, but we know that the opposite angles themselves are congruent. However, this is the first time we've seen something like this, where the diagonals actually bisect opposite angles. So I'm actually going to go ahead and draw some things into this diagram right here. And I want you to go ahead and do the same. I'm just going to get here's my ID card. So I'm going to draw on a diagonal here and across this way. So we are told that the diagonals are perpendicular, which means we've got four right angles in the middle. So everything here is a right angle. I'm only going to put one because if there's one, that means that they're all 90 degrees. Not only that, it says that the opposite angles bisect each other. So the entire angles opposite each other are congruent, but now the angles, so like this angle here is congruent to that angle there. Because the whole angle has been bisected. And because the opposite whole angle is congruent to this whole angle here, that means that these two also get two congruent markings. So all four of those angles are congruent. So for example, if this angle was 60 degrees in total, this angle would also be 60 degrees in total. And because the diagonal bisects it, that means that all four of those would be equal to 30. If this angle up here is 120 and that one down there is 120, that means that these are also being bisected. So each one of those four would be 60. So lots of information that we've got here. Next thing we're going to talk about is a square, and then we're going to do some math. So, questions so far? So these are in addition to, or these are specific to rhombi. These particular rules don't really apply to a generic parallelogram, and they don't apply to a generic rectangle. They only apply if you can get it specific as a rhombus. Now, the last definition that we're going to be talking about today is a square. And you all know what squares are. A square is a parallelogram with four sides and all four angles congruent. So I'm going to go ahead and put in a right angle at each corner. So a square, by the way, is the most specific type of quadrilateral you can get. A square is a quadrilateral. It is a parallelogram. It is a rectangle. It is a rhombus. It is all four of those things at the same time. So every rule that we have for parallelograms applies to squares. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other. All four angles are 90 degrees. The diagonals are congruent. All four sides are congruent. The diagonals are perpendicular. The diagonals bisect opposite angles. Like there's 10 things that are specific to squares. Lots of things that we learned about parallelograms, all of them apply to squares. So right here, all of the properties of parallelograms, rectangles, and rhombi apply to squares. For example, the diagonals of a square bisect each other, are congruent, and are perpendicular. So if you were to draw, do this one more time. If you were to draw the diagonals, and if you just want to sketch them quickly, that's fine. Or if you have an ID card and you want to make it a nice straight edge, you're welcome to do that. So here, like that. So there you go. They bisect each other, diagonals bisect each other, they are perpendicular to one another. All kinds of specific things happening within a square. We could put more congruency markers in there if we wanted to, but we're not going to worry about it. So I'll just ask you this though. If each angle in a square is 90 degrees and the diagonals bisect the opposite angles, how many degrees is each one of these small angles around the outside? 45. Yep. There are 8 45-degree angles that the diagonals split the corners into. So every single one of these triangles is a right triangle that has a 90-degree angle, a 45-degree angle, and a 45-degree angle, which adds up to 180. You got it. So let's go back and talk about some rhombuses here with this first example. If the length of LM is equal to 2x minus 9, and it's not marked on the paper, I'm going to mark it on the paper. 2x minus 9 goes right there. That's the length of LM. The length of KN is x plus 15. Solve for x. All right, well, because all four sides are congruent, that means opposite sides are also congruent. So that means that these two are what? Those two are congruent. So LM is congruent to KN by the definition of a rhombus. By the definition of congruence, that means that LM is equal to KN. And if you substitute in the two expressions, we get 2x minus 9 is equal to x plus 15. Now, if you were solving this, I would just expect you to start here. 2x minus 9 equals x plus 15. Solve for x. Tell me what you get. What do we think x equals? $24. Yeah, that's what I got. Yeah, if we write the equation right here, that would be 2x minus 9 equals x plus 15. We'd have to subtract x from both sides. So if you take away x from here, it goes away. If you take x away from here, it goes from 2x to 1x, which is just x. And then if you add 9 to both sides, 15 plus 9 is 24. Therefore, x is 24. Great. That's the answer for that example there. Questions on that? Cool. Let's keep going. I want you to answer all 3 of those. I'll give you 3 minutes. We'll average 1 minute per, and we'll check back in. We got a quadrilateral. Tells us it's a rhombus. Solve for xz, measure of angle xyz, and the measure of angle wxz, using the given information. It's always a good idea to put that given information on the diagram as well. I would definitely, in fact, I'm just going to do that right now. AZ equal to 14. VY 2. So before I'm doing any math, I'm going to mark all that. Because all those things have to be true because it's a rhombus. I would say of these three things, the last one is going to be the most challenging. The first one I'm hoping is pretty easy. What is the answer to XZ? Which is 28. XZ is 28. The diagonals bisect each other. XZ is the entire length of this diagonal. Half of it is 14. Double that value, the whole thing's 28. The measure of angle XYZ. So XYZ, if this is 35, that's 35. XYZ is a combination of both of those things, so 70 degrees. So the first two are just doubling a couple of values. The last one, though, we need to remember some other things about parallelograms in general. And that's the fact that we're trying to figure out, first of all, the measure of angle WXZ, which is that one right there with the double marking. So the first thing we need to do is figure out, well, I guess there's a lot of different ways we could do this, actually. And now that I think about it, there's probably an easier way to do it. But if we think about parallelograms in general, we know that consecutive angles in parallelograms are supplementary. So you could do that way. Alex, do you have another way? This one right here. Yep. Yeah. Like this guy here?
Yeah.
Cool.
And then WY equal to 35. So on the other side of it, it's 5Y. Yeah, so then that's 35. So on the other side of it, no, there, the other side of it, that has to be 35.
Okay.
Even though the middle is gonna be 90 because that's the rule.
Yeah.
And then, so you take 180 minus 90 minus 35 and you get 55. And then those two are convenient.
Cool. Yeah, WXZ is 55. There's a lot of ways to go about it. That's one of them. So yeah, I think maybe the quickest way would be to see, okay, I've got a right triangle here. All four of these triangles are right triangles. So if you got 90 here, cool. We got 90 here, which means that we know this one's 35 because all four of those are 35 degrees. And so if you take away 35 from the remaining 90, 55. Or you could say, this whole thing is 70, and it's supplementary with this angle here, so this one has to be 110, because 70 plus 110 is 180. Split 110 in half, 55. Or we could say we got this big triangle here, which is an isosceles triangle, because that's the same as that. That's 35, that's 35. Those add up to 70. Take away 70 from 180, which means this whole thing is 110, divide 110 by 2, 55. There's a lot of ways that we could go about figuring out that the measure of angle WXZ is 55 degrees. Any questions on that? A lot of different paths we can take. All right, let's check out example 2 then. I don't see a lot of hands up, so, or any. Number 2. use the diagonals of a rhombus. It tells us what we're going to be doing. We're going to use the diagonals of the rhombus. So the diagonals of rhombus K, L, M, N intersect at P. And if they intersect in a rhombus, that means they intersect at what angle? Diagonals intersect at what degree in a rhombus? 90. So that's the right angle. Let's see, what else? The measure of angle LMN, what's up? Always, yeah, in a rhombus, the diagonals are always perpendicular. Yep. Angle LMN is 75. Okay. So this whole angle all the way across is 75 degrees. Find the measure of angle KNP. So KNP, here's K, here's N, P. So KNP is this one. We're trying to figure out how many degrees that angle is, right there. So we'll just walk through this because it's going to do most of the work for us. So it says, because we know KLMN is a rhombus, we can use the definition of a rhombus to say that the measure of angle LKN, the measure of angle LMN, are congruent opposite angles. So LKN and LMN. So across, so that means that this one over here is 75 degrees as well. That's what we're going to say. They're congruent because opposite angles that are bisected, okay, bisected by a diagonal KM. So because KM is a bisector, the diagonal is a bisector of this angle and that angle, that means that the measure of PKN, which is this part right here, is half of the measure of angle LKN. Half of 75 is what it's saying. So it's equal to half of 75, which is 37.5. So we're saying that the measure of PKN is 37.5. That's this one right here. 37.5 degrees for PKN. That's what it's saying. Because the diagonals of a rhombus are perpendicular, the measure of angle KPN is 90. All right. So that's just the angle in the middle. And then it's going to use the right triangle on the bottom. It's going to use triangle KPN right here. We've got a 90-degree angle here. We have a 37.5 degree angle there. So if we take those away from 180, that'll give us the angle that we need. So it sets it up by saying the three angles add up to 180. 37.5 plus 90 plus that angle we need is equal to 180. That would be a substitution step. So substitution. So how many degrees is the measure of angle K and P? 52.5. Good. Really, the only math you need to do here is 90 minus 37.5. Because every single time you're dealing with triangles that are made out of a rhombus or a square, they will always be right triangles. Therefore, the other two angles will always have to add up to 90. So you can always just kind of get rid of the 90 from the beginning because you don't need one of them. So you only need to figure out half of the rest of it because half of the triangle is taken up by 1/8. Any questions on that? 52.5, 45 for that. Next one, square time. All right. Using the definition of the squares. So EFGH is a square. The length of FJ is 19. Find the length of FH. This is a lot of work to do multiplying by 2 or adding 19 to 19. FJ is 19. I would not expect you to do a lot of work for this, especially not that much work. Because the diagonal is being cut in half. If half of it is 19, you're trying to find the whole thing, just double it. 38. So we'll fill some things in here though. Congruent to equal, so we're just going to write JH here. Substitute in, so that's going to be JH is equal to 19. FJ plus JH is equal to HF or FH, because it equals the entire thing. Each of them is equal to 19, so that's 19 plus 19, and so the total is equal to 38, which we could have done a lot quicker just by recognizing that they were the same length, so we can just multiply by 2. That's what I would suggest here. Now, I gotta say, I do like that they're kind of using the proof idea on a lot of these because it goes back and it makes you interact with a lot of the properties and things that we did earlier. So you keep seeing those over and over and you refresh those a lot, which I appreciate. So in the notes, I think it's a great thing. On the assignments, I would not expect you to write all that out. All right, check step. I want you to answer all four of those, or not all four of those. You're only answering one. It's a multiple choice. Okay, answer that multiple choice question. Got about 10 more minutes. Here you go. This is an interesting question. Anybody think they know it? There's nothing missing. Anybody know what X is? X is 9.5. Okay, why? And by the way, you do have to solve for X first on this one. Why does X equal 9.5? Because 4X plus 3 equals 41. Yeah, if it's a rhombus, then those two sides have to be equal because all four sides are equal. So over to the side, let's just go ahead and do a little bit of math over here. So 4X plus 3 equals 41. Subtract 3, 4X equals 38. Divide by 4, X equals 9.5. Half of 38 is 19. Half of 19 is 9.5. So X equals 9.5. All right. Now, we still need to figure out what Y is equal to, but we can write in 2 times 9.5 because X is 9.5 plus 4Y is equal to what? Close, yes. 2X plus 4Y equals 45. Why do we know that? Every angle in a square is 90 degrees, and because it's a rhombus, the diagonal does what to each angle? Cuts it in half. Half of 90 is 45. Therefore, if this is going to be a square, 2x plus 4y has to be equal to 45 degrees. Any questions about that? We're basically saying this because of that, so this because of that, which means that this has to be 45, that's 9.5. So if we do the math, y equals 6.5. Good. So 2 times 9.5 is 19. 19 plus 4y equals 45. Subtract 19, 4y equals 26. Half of 26 is 13. Half of 13 is 6.5. So y equals 6.5. Answer is A. All right. That was a fun question. I like it. Okay. That's pretty much it for like learning about rhombuses and squares. Now we're going to flip it around and we're going to test for rhombuses and squares, which we kind of just did right here. Testing for rhombuses and squares is basically the same thing as what we did with testing for parallelograms. So it's going to say things like, what does this value need to be if the shape is going to be a rhombus or if the shape is going to be a square? So the next theorems that you see are basically going to be the same as the theorems we saw earlier for rhombuses and squares, but it's going to start with the properties and then end with rhombus or end with square. So if a parallelogram meets certain conditions, you can conclude that it is a rhombus or a square. So for example, if you have a parallelogram and you know it's a parallelogram and the diagonals are perpendicular, that means you have a rhombus at the very least. If you have a parallelogram and one diagonal bisects a pair of opposite angles, then you've got a rhombus. Now notice it says only one diagonal. You don't need to prove that both diagonals bisect opposite angles, because if you have a parallelogram, if one of the diagonals bisects the opposite angles, that automatically means the other one will as well. So you only need to prove that one of them does. If two consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So if you have a side and then a side next to it, and those are the same length, then it has to be a rhombus, because we already know opposite sides are congruent because it's a parallelogram. Therefore, consecutive sides are congruent. That means that all four sides would be the same. The last one says, this is about a square, if a quadrilateral is both a rectangle and a rhombus, then it's a square. Okay. So this next one is going to be like a little paragraph proof. Again, I skipped all the proof questions in your assignment, but we'll do a little bit of a proof here. So this says to write a paragraph. Given TUVW is a parallelogram, prove that triangle TSW, that's the triangle on the left, is congruent to triangle TSU, which is the triangle on the top. So first thing we know, because it's a parallelogram, we know that TU is congruent to WV. We also know that TW is congruent to VU. We also know that the diagonals bisect each other. So TS is the same as SV and WS is the same as SU. All of those things are true. Opposite angles are also congruent. I don't know if we're going to do much with that. I'm going to just stick with this for now. So I actually think that's enough right there to say that they're congruent, because what could we use to prove that this triangle is congruent to that one? The left and the top one. How can we say they're the same? Oh, wait, it tells us that they're the same already. We would be using side, 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 though. Sorry, that's another condition that is given. We have to prove it's a rhombus. Okay, so because it's given that the triangles are congruent, it must be true that blank is congruent to UT. What's that? Let's look at the triangles here. UT corresponds to what over here? WT. Yeah. See you later. Have a good weekend. So UT would have to be the same as WT if this triangle is congruent to that triangle. So I'm just going to put a double marking right there. So we're going to say WT right here. You can use the triangles to figure out what parts correspond between the two. So UT would be third to first on this one. So if we go third to first on the other one, it's WT. So WT is congruent to UT. Because WT and UT are congruent, consecutive sides of the given parallelogram, are consecutive sides of the given parallel. Okay, yeah, they are consecutive sides and they are congruent, which means that it's a rhombus. So that means all four sides are the same. There we go. That was a quick little paragraph. All right, let's use a rhombus now. And I've said this a couple times, but I can't really emphasize it enough. This study tip over here is very important. The conditions for rhombi and squares only apply if you already know that the quadrilateral is a parallelogram. If you don't know it's a parallelogram, it doesn't necessarily mean that you're going to get a rhombus or a square if you have certain conditions. It has to first be known that it's a parallelogram. So let's take a look at this one here. Garment design. That looks like some sort of plaid or argyle rather. Yeah, argyle pattern. There it is. Ananya is designing a sweater using an argyle pattern. All four sides of quadrilateral A, B, C, D are 2 inches long. Okay, so 2 inches, yeah, 2 inches. 2 inches up here, 2 inches over here. Every side has a length of 2 inches. How can Ananya be sure that the argyle pattern is a square? So first of all, we know that all four sides are the same. We don't know if that means it's a rhombus, because we don't yet know if it's even a parallelogram. But we do know it's a parallelogram. Why? So that would make it a rhombus, but we have to prove that it's a parallelogram before that. So like right over here, at the bottom right, in order to say it's a rhombus or a square, you have to already know that it's a parallelogram. How do we know that this is a parallelogram? What is the condition of parallelograms that makes a quadrilateral a parallelogram? The opposite side lengths are congruent, yeah. So because, right here, a square has all the properties of a parallelogram, a rhombus, and a rectangle. So to prove that the quadrilateral is a square, prove that it's a parallelogram first, then a rhombus, then a rectangle. So it is a parallelogram because the opposite sides are congruent. And look at that right there. Because both pairs of opposite sides are congruent, that means that it is a parallelogram. That's actually really nice that they drew it again for us. All right, now, because blank sides of the parallelogram are congruent, that means it's a rhombus. What's the thing that we just saw on the previous page? One of our theorems. Blank sides of the parallelogram are congruent. What does it say about sides of a parallelogram and making a rhombus? In one of those theorems at the top of page 439. Blank sides of the parallelogram are, what word goes here? We could say that. The one that we're looking for specifically, though, is 719. Yeah, if two consecutive sides of a parallelogram are congruent. So if we say consecutive, that's enough. But yeah, all sides are congruent as well, which also means it's a rhombus. But I'm going to go with consecutive. But all four sides being congruent also works. So because consecutive sides, like AB is next to BC, so 2 and 2, consecutive sides of the parallelogram are congruent, that makes it a rhombus. Now, the last thing that we would have to prove is something that would make sure that this is a square. What is the only thing here? Well, the only thing says if it's a quadrilateral and a rectangle. So we'd have to prove that somehow it's a rectangle. So the way to prove that it's also a rectangle would be to prove that the diagonals are congruent. So if the diagonals of a rectangle are congruent, that means the parallelogram is a rectangle. Congruent diagonals means it's a rectangle. So if Anya measures the length of each diagonal and finds that they are equal, that would mean that it is a what? It means it's a square. Yeah. So you got to prove that it's a parallelogram and prove that it's a rectangle. And once you have parallelogram and rectangle and rhombus, you can put it together to say it's a square. So yes, we could prove it. No, we're not going to, but we could, but we're not going to. Okay. So let's keep going. You could use, by the way, if you were going to prove this, you could use the Pythagorean theorem to prove that the diagonals are the same way. So moving on. Classifying using coordinate geometry. These are the ones that are probably going to take the most amount of time because they have the most math involved. Distance formula, slope formula, whatever else you might need to use. Perpendicular slopes, things like that. So determine whether quadrilateral, oh no, it doesn't say quadrilateral. It says parallelogram. That's the symbol for parallelogram. So we know we're starting with the parallelogram. So that's good. Let's put the points on here. -3, 2 for A. There's A. B is at -2, 6. Right up here. C is at 2, 7. Right there. D is at 1, 3. Right there. Now, this is not a situation where you can just look at it and give an answer. You need proof. So, we know we have a parallelogram, right? It tells us that. Parallelogram ABCD. So we need to figure out, is this a rectangle? Is it a rhombus? If it's both, that means it's a square. So we have to test for two specific kinds of parallelograms here. We have to test to see if it's a rectangle, and we have to test to see if it's a rhombus. And if we can prove either one, if we can prove one of them, we can say that. If we can prove both of them, then we can say it's a square. So this one starts off by saying to plot and connect the vertices on the coordinate plane. We've done that. I'm going to label these as well, just so we know where we're at. There's A, B, C, and D. Okay. For parallelogram ABCD to be a rectangle or a square, then all four angles have to be perpendicular, right? They got to be right angles, which means the slopes would be perpendicular, which means they would be opposite reciprocals. So if we look here, the slope between A and B, if you go from A up to B, you go 1, 2, 3, 4, up 4 over 1, which is a slope of 4. It tells us that right there. If you find the slope between A and D, you go up 1 and over 4. So that'll be a slope of positive 1/4 and a slope of 4. Are those both opposite and reciprocal? Or is it just one or the other? I would definitely say they're reciprocal because 4 over 1 and 1 over 4 are reciprocals, but opposite means that one of them would be negative. One of them would have to be positive, one would have to be negative for opposites to exist as well. So because we only have reciprocals, but not also opposites, that means we don't have 90-degree angles, which means it can't be a square, and it also can't be a rectangle. Everybody good with that so far? No square, no rectangle. We just did that by figuring out the slope of only 2 lines. So it doesn't take very long to figure that out. So if you're testing, that's actually a really good way. They've finally done something that I would suggest doing to start off with. They didn't use the distance formula first, which is brilliant. That's a good thing. So definitely do that, because if you can show that the sides are not perpendicular to each other, you can say for certain it's not a square and it's not a rectangle. So now we just have to figure out, where'd you put? Is it a rhombus? So to prove that it's a rhombus, if it's a rhombus, let's take a look down here. Because the product of the slopes is not -1, by the way, perpendicular slopes, if you multiply them together, they always equal -1. I usually go with opposite reciprocal, but it's also true that if you multiply them together, they equal -1. Whereas if you multiply those two together, you get +1. So it's still not perpendicular. The sides of the quadrilateral are not perpendicular. Therefore, it is not a rectangle or a square. Okay. So then oh man, it's finally doing things in the most efficient way. This is great. Because we could test to see if it's a rhombus by checking if two of the consecutive sides are congruent by using the distance formula twice, which distance formula only twice, not too bad. But the distance formula definitely takes more time than calculating slope. So we learned not only if consecutive sides are congruent, it's a rhombus, but we also learned that rhombuses also have perpendicular diagonals. So instead of figuring out the distances of consecutive sides, let's figure out the slopes of some diagonals. So if you draw your diagonals in, and we find the slopes of the blue lines, if those are perpendicular, that means it's a rhombus. So I'm proud of this book now. It finally did something that was like the most efficient way to do the problem. There are other ways to do this. This is the way that I would recommend doing it. So if you test the slopes of the diagonals, AC, so to get from A to C, you're going to go 1, 2, 3, 4, up 5, 1, 2, 3, 4, over 5, 5 over 5, right here, which is 1. From B to D, you're going to go down 1, 2, 3, and over 1, 2, 3. So negative 3 over 3, down 3 over 3, which is a slope of negative 1. Now, if you look at these two numbers, 5 over 5 and negative 3 over 3, those are not exactly opposite reciprocals of one another. However, once you simplify them, and if you were to write them as a fraction, 1 over 1 or negative 1 over 1, if you flip them over, they're still both 1 over 1, and we have a positive and a negative. So they are opposites and reciprocals, which means the diagonals are perpendicular. So because the products of the slopes of the diagonals is negative 1, if you multiply the slopes together, and you get negative 1, that means they're perpendicular. The diagonals are also perpendicular. So that means it's a rhombus. And we didn't have to use the distance formula to show that all 4 sides were the same. That's kind of nice. All right. That's all I got for you. We got about 15 minutes to get working today, so that's not bad.